the thing which is left of lechatelier is our 2-3 points basically. What happens when there is a addition of a inert gas? Okay, let's study this. This is a important thing to know. Okay, in the addition of inert gas at equilibrium, we dealt with case 1 in the previous class. Let me revise it to you. Whenever we add a inert gas, for example, is helium, neon, argon, krypton, all those gases which don't affect a reaction, which does not take part in a reaction. Those are known as inert gases. So we have to see how does a inert gas, addition of an inert gas at equilibrium affects the equilibrium reaction. Okay, so it is studied, the addition of inert gas is studied under two cases. Those two cases are constant volume and constant pressure. So the case of constant volume is very easy. Why is it easy? Because when you are adding inert gas at constant volume, the volume is directly proportional to moles. So volume is not going to change. Why? Because you yourself have taken volume to be constant. And since moles are directly proportional to volume, moles will also not change. Okay. And if moles are not going to change, the reaction cannot change itself. Why? Because the reaction changes only by the way of moles. Shift towards more moles or shift towards lesser moles. Okay. But if there is no change in moles, no change in volume, then the reaction, the equilibrium will not change, will not shift anywhere. Very simple. Case 1 is simple. Now, case 2, this we have not done. We'll do it now. Case 2 is at constant pressure. Okay. Now, we have to understand one thing, something about constant pressure. Niranjan, can you read the lines which are written underneath case 2 at constant pressure, starting from here, maintaining?
Maintaining a constant pressure requires a flexible container which can adjust the volume so as to keep pressure constant. If you add,
Okay.
if you add more of a
Oh.
gas,
All right. So, so what does it tell you? It tells you in order to maintain a constant pressure, you need a flexible container. The walls of the container cannot be rigid. It has to be flexible. For example, a balloon. Okay. So I have given you the example of a balloon. Let's read this as well. Can you read the first point, the example?
if you add more of gas, inert gas, the balloon will expand in volume while the pressure exerted on the balloon outer surface is always constant. That is,
Oh, I'm sorry, that is 1 atm. That is, this is not constant. This is, of course, this is constant, and that constant value is 1 atm. Okay, so what I'm trying to tell you is, please observe in this figure 1, this is figure 1, this is figure 2. In these two figures, figure 1 is a deflated balloon, less amount of air. Figure 2 is having more amount of air inside the balloon. But please observe, the pressure outside the balloon remains same, 1 atm, and that is constant. Okay, so what does this example, practical example, tells us? That at constant pressure, when you add more amount of inert gas, the volume increases. Please tell me, does it make sense that increasing the amount of gas will increase the volume? Yes, please. Utkarsh, is it making sense? Yes?
Yes, sir.
Okay. Yes, it is very easy to understand. Whenever you will blow air into a balloon, it will expand. Obviously, it will expand. And if this is the case, then please observe, when the volume increases, number of moles will also increase. So I can say that at constant pressure, whenever I add more amount of inert gas, the equilibrium will shift towards a direction where more moles are being produced. I hope
Uh,
it seems
Sir, in the
logical to
last
you.
class, we
Yes.
had seen that if we increase the number of, if we increase the volume, then the moles will also increase. But and if we increase the pressure, then the moles will decrease because pressure and volume are inversely proportional.
That is correct. But here
Sir,
we are taking constant pressure.
no, but sir, according to PV equal to nRT,
Uh-huh.
sir, pressure and moles are also proportional.
See, that is true. Things are proportional, provided the other things are some things are constant. Okay. See, PV is equal to nRT. Let me tell you how PV is equal to nRT works. PV is equal to nRT. I can say in PV is equal to nRT that P is inversely proportional to V only till N, R, and T are constant. Okay. Then I can say, writing another equation, similar equation under different circumstances, I can say that volume is directly proportional to moles till P, R, and T are constant. Okay. So whenever I take a relation between two variables, then the other variables combined value of other variables has to be taken constant. Okay. That is the thing. Now, in this case too, what I have taken is, I have taken pressure to be constant. Pressure is constant. Also, the temperature is taken to be constant because outside, if you are taking the balloon, then the temperature is constant. Okay. So, the relation between volume and moles is direct. So, there can be different
So,
relation
sir, but
from PV is equal
in
to
the
nRT.
last class we had done that pressure is inversely proportional to number of moles, but that is not the case. Pressure is also directly proportional to number of moles, and volume is also directly proportional to number of moles, but pressure is inversely proportional to
But did
volume.
I but did I teach you pressure is inversely proportional to number of moles, or did I teach you pressure is inversely proportional to volume?
So you are taught that pressure is inversely proportional to volume, and volume is directly proportional to
Yes.
moles.
Yes. So that was a very clever thing. Pressure, I cannot say is inversely proportional to moles. Okay, that is false. But I can very well say pressure is inversely proportional to volume, and volume is directly proportional to moles. Okay, now let me tell you one thing here. The thing which I am teaching you in the lechatelier is a very easy version. Is a very easy version. Also, this thing is known as funda. This is funda. This is not the absolute logic. This is not the absolute logic. Not absolute logic. What I am teaching you is not absolute logic. This is basically a funda. Now, there is a difference between a funda and absolute. Absolute logic or the proof can be proved or can withstand circumstances or can be proved irrespective of anything. But on the other hand, the thing which I am teaching you is a funda. Now, funda, there is a limitation of funda. You can never prove a funda. You can never prove a funda. But on the other hand, experience people can give you a funda which is applicable everywhere without exception, can be applied everywhere. The only limitation being you can never prove a funda. Okay, so I am very cautious with my words when I tell you the relation between pressure, volume, and moles. I will never say pressure is inversely proportional to moles because it is not. You remember in the starting of the lechatelier, I said the shifting of the equilibrium depends on the moles. I said if you are a equation, if you consider yourself a equation, you can either go forward or go backwards. This is the only thing you can do and you are capable to do. Rest other things you can do. You cannot walk out of the container. If you are a reaction, you will be placed inside confinement. The only thing which you can do is move either in the forward direction or the backward direction of the equilibrium. That is the only thing which you can do. Now, the things which are in your control, please observe the things which are in your control. What are those things? Those things are, if there is a difference in the moles, if there is a difference in the moles, okay, then you can affect your equilibrium. Okay. How? By the change of volume. By the change of volume. By my experience, I can tell you, please observe, the only thing which changes our equilibrium is volume. Okay. Mostly it is changed by the volume, not by the pressure. It is changed by the volume. Okay. Directly. And volume is directly involved with the moles. Whenever you change a pressure, you should think in your mind that the pressure will never directly affect the moles. Pressure will affect the volume. Okay. And the pressure and volume relation is always inverse, is always and always inverse, will never be a direct relation, is always inverse. And volume and moles relation is always direct relation. Okay. So if the pressure is changed, please see the effect on the volume. Never see the effect on moles, see the effect on volume. Then after calculating the effect on volume, please notice the effect on the moles. This is how you go. If you take direct effect of pressure on moles, your answers will be wrong. Again, I'll repeat my sentence. The things which I am teaching you in lechatelier, especially, these are funda. Because the funda, by funda only can you evaluate objective questions in the time frame of the competitive examinations. Okay. The
That means
logics.
pressure is directly proportional to moles can not be proved, but it's a funda.
Repeat again.
That pressure is directly proportional to moles cannot be proven.
It can be proven. It can be proven that pressure is directly proportional to moles, but the thing which I am telling you, the funda which I am giving you is, we will not take the relationship between pressure and moles. We will not consider relationship between pressure and moles. Now your question should be, sir, if you are not going to consider the relation between pressure and moles, how will the pressure affect the equilibrium? I will say that we are going to see the relation only between pressure and volume, never between pressure and moles, only between pressure and volume. Why? Because pressure has direct bearing on the volume, not on the moles, on the volume. Okay. Let me tell you something else. You will appreciate the fact that pressure and volume are the physical quantities. Pressure and volume are not the chemical quantities. While when a reaction shifts from one direction to the other, the things which are changed first of all are moles. Things which are changed are first of all the moles. Let me give you an example. Why am I saying that? Let me give you an example. Please see. Let's take Haber's equation, Haber's process, which is H2 plus N2 gives you twice of NH3. Now, this is the equilibrium reaction. Please observe that in going forward, the first thing, the change the first change which you notice is from 4 moles to 2 moles ratio. This is the first thing which you see. Okay. You don't see, first of all, change in anything else. The first thing which a reaction does to itself is change in the number of moles. Please tell me, am I correct? If I say I have an equation and that equation goes from left to right. In this particular case, let's talk about this particular example. So the first thing you are noticing, which you are noticing evidently, is it change in the number of moles or is it something else? Please tell me. Yes?
A change in
Am I
the
correct?
mole.
Obviously, it is change in the moles because it is evident, it is written there. 3 is to 1 is to 2. 3 plus 1, 4. 4 is to 2. Charan, is it making any sense? Yes?
Yes, sir.
Okay, okay, all right. So the first thing which I told you in starting of the lechatelier principle, I will repeat it again. The only thing which changes a equation, which changes the equilibrium in a equation is the moles. And there are many instances in which I have told you, if, and in caution I have made you write it down, caution, if delta Ng is equal to 0, no change in equilibrium. Did I tell you that? Please tell me.
Yes, sir.
Yes, I did tell you. So I didn't tell you that whenever a pressure increases or decreases, there will be a change in volume and there will be a change in moles. No, it is the other way around. If the reaction is not telling you that there is a change in moles, then nobody can affect a equilibrium reaction. By nobody, I mean pressure or volume cannot affect, and inert gas also cannot affect. Okay. Now, if only if delta Ng is not equal to 0, that is, there is a difference in the moles at the reactant side and the product side, will there be a difference. And whenever there is a difference, there can be a shift in the equilibrium. And very, very meticulously, you have to find the shift. You have to only use relation of moles is directly proportional to volume. Nothing else. Moles are not proportional to anything but volume. And this logic, this is a funda. This is a funda. What do I mean by funda? By funda, I mean do not argue it with your friends that moles are directly proportional to volume and not to the pressure. Okay. Moles are very much directly proportional to pressure, but in this particular case of lechatelier principle, I am teaching you a funda. Do not use moles directly proportional to pressure. Only use the relation between moles and volume to change a equilibrium reaction. If you have to take into effect the pressure, if you have to take the effect of pressure onto equation, do not go to moles directly. Do not go to moles directly. There is no direct way to reach moles. You have to go via volume. You have to go volume. First, you will search the pressure and volume relation, which is inversely proportional. Then you will see the volume and the moles proportionality, which is directly proportional. Okay. Only then are you going to reach the moles. Okay. So this is my explanation for the this inert gas at constant pressure. Let's do one thing. Please copy case 2 and then we'll ask other people who have studied this before, how do they calculate this particular case? Is there any other method they use? Okay, but before you forget anything, please copy it down. Important case. This is an important case. I hope case 1 you have already written. Or should I show you the case 1 as well? Copy case 2, all right.
So what was case 1?
Let me know when you have. Case 1 is very simple. Case 1 is at constant volume. There will be no change. No change in equilibrium happens. See both the cases. Write it down. Let me know when you have. The things which I have taught you in the lechatelier, I have not given you the proofs. Although I can give you the proofs, but the proofs will not let you solve the questions because the proofs are very lengthy. By the time you will apply proof, already 15 minutes, 10 minutes would have been gone. Very, very stupid question which you could have done in half a minute. So these fundas are very, very powerful. I have observed it over the years, solved many questions on them. They will not fail you anywhere. They are rock solid, tried and tested. And nobody asks you to prove these results actually. These are theoretical questions to be half a minute or maximum 1 minute.
They're done. Scroll down.
Yeah. Is there a different way, any different way the Fiji has taught you how to calculate the effect of inert gas? Any? Charan? Any other way they have taught you people?
No, sir.
So have they taught you anything regarding this application of lechatelier at inert gas, or have they skipped this part?
Sir, they taught.
Okay, so can you share with us what did it teach you? How to evaluate it? I mean, it cannot be exactly the same what I am teaching you. It might be a little different.
Done.
So done.
Okay. Okay, so you can write the result as well, although you know the result. Result is reaction will move in a direction which favors increase in the moles. So for what condition is this result? The condition was addition of inert gas at constant pressure. Okay. Whenever there is an addition of inert gas at constant pressure, the image which should come to your mind is of a deflated balloon you are trying to inflate. Okay, you are blowing air inside the balloon and the balloon volume will automatically increase, and it is satisfying our criteria. How? Because the outside pressure, which is atmospheric pressure, is constant. That is 1 atm, and the volume will increase. And I have told you there is a direct relation between volume and the reaction, equilibrium reaction. If the volume is increasing and if delta Ng is not equal to 0, then definitely the reaction, the equilibrium will shift in a direction which favors increase in the moles. If anybody has a different technique to calculate what is the effect of inert gas, any logic, any proof, please share with us. Would love to hear it, because over my time of experience, the thing which I have just told you now is the simplest one. Although I have seen many combinations, or should I say various theories, but among them, this theory which I have just told you now, I have developed it over time. This is the funda basically, and it will never fail you. Tried and tested on many questions. Let me know when you have written this. We will do two more effects. One of temperature and the other of catalyst. That's it. The chapter is over. We'll do some questions. Also, we'll shift to the next chapter, which is GOC, General Organic Chemistry.
So done.
Okay. Sharan, done?
Yes, sir.
So done.
Okay. All right. Let's move to the other two concepts, which are simple. The others are simple now. Then we'll do the questions. Okay. The fourth one is changing temperature at equilibrium. So, what does the change in temperature at equilibrium do? We all know changing the temperature at equilibrium changes the value of equilibrium constant. That is Kc or Kp both. Okay, because both are the equilibrium constants. Now you know the equation which is responsible for the relation of temperature and the equilibrium constant is known as, can anybody tell me the name of the equation which tells you the relation of temperature with the equilibrium constant? Yes, anyone? Written on your screen. Van 't equation. Please, this is the this is the Van 't equation. Very famous equation. It gives you the relation of the equilibrium constant with the change in the temperature. Okay. Now there are two cases in this. Now the variation of equilibrium constant depends upon the delta H, something known as delta H. You know delta H. What is delta H? You have studied in thermodynamics. Please tell me.
The
Yes, yes.
heat or enthalpy. The the
Enthalpy change.
Yes, sir, the enthalpy change.
Enthalpy change. Yes. And if I ask you enthalpy change, can anybody tell me enthalpy change is the difference of two quantities? Can anybody tell me what are those quantities? We have studied it in previous classes, previous lectures. What is the, I'll repeat my question. What is the delta H given by? Delta H is given by difference of two quantities. Okay. Give me those quantities, two quantities. Anyone? No? Activation energies. Was it activation energies? Delta H is equal to forward activation energy minus backward activation energy. Okay. Delta H is equal to
EAF
forward
minus
activation energy minus
EAR.
EAB. Yes. EAF minus EAB. Delta H is equal to EAF minus EAB. See, these are small things which you will have to remember. Okay.
Would there be a log in the
Now,
formula?
log can come. Log can come. It's not a big issue. You should be prepared for log, any other conversion for that matter, because you are preparing for competitive exams. So log should not pose any problem to you. Okay. Now, let's move further. So these are two cases. We'll discuss two cases. Please see case one. In case one, we are endothermic. Can anybody tell me what is the endothermic reaction? What is the endothermic reaction? Can anybody tell me?
Absorbing heat is absorbed reaction.
Yes, yes.
Delta H is
Heat
positive.
absorbing reaction. Yes, delta H is positive and heat absorbing reaction. Okay, those are known as endothermic reactions. So I say for delta H is greater than 0, K is directly proportional to T. What do I mean by that? I mean, if T is increasing, if temperature is increasing, then the equilibrium constant will also increase because it is directly proportional. Now you will ask me, sir, how do you know that this is the case? So I'll explain it to you. Please observe the equation, Van 't Hoff equation. Please focus. If delta H is positive, this whole figure is positive, then I can say K2 by K1 is directly proportional to T2 minus T1. Okay, and rest other things are constant. Rest other things are constant in a positive constant. Why? Because delta H 2.303 R T1 T2, these all are constant values. Okay. Now, if we increase T2, this whole difference T2 minus T1 increases. And if this increases, this whole fraction increases. And if the fraction K2 by K1 increases, then I can say the numerator should increase more as compared to the denominator. Only then the fraction K2 by K1 would be more. So I can say K2 is greater than K1 if T2 is greater than T1. Tell me, does it make any sense?
Yes, sir.
So what are
Okay,
K2 and K1?
that is great. That is a very, very good question. I mean, we are observing the change in equilibrium constants. So wouldn't it be logical that K2 and K1 are the equilibrium constants? K2 is a equilibrium constant at temperature T2, while K1 is a equilibrium constant. Yes, while K1 is a equilibrium constant at temperature T1. Please write it down. Please write it down before you forget it. Give this heading. Copy this whole thing. You will have to keep on revising these small concepts. Why do I say that? Because a good question in competitive exam will involve one of 2-3 chapters. okay, simultaneously. So you will be puzzled which formula to use, okay, because you will be using more than one formula there of belonging to more than one chapters.
So what difference will it make if there is log K2 by K1?
You want to do it in the terms of that can be done, but that would be a unnecessary derivation. I mean, I can place logs on both sides. I can open up the expression, but why would you like to do it? You can try it on your own. I mean, log K2 by K1 can be easily said log K minus log K1. Okay, you know the rules of log. Log A by B is equal to log A minus log B. You can split it. That is not at all. Those small variations can be done. We'll see some of the questions, then you'll come to know the variations.
Sir, done.
Mm-hmm. Yes, Charan, done?
Yes, sir.
Okay, let's move ahead. Oh, time is less than 1 minute left. Let's rejoin.